Hello class, in this video we will learn how to predict whether a redox reaction will occur spontaneously or not. In the previous video, I've mentioned that spontaneous redox reactions occur when a strong oxidizing agent reacts with a strong reducing agent. This still holds true, but another key criteria is that the overall cell potential will be greater than 0 volts. In other words, it needs to be a positive value. It's worth mentioning that when you do have reactants mixed together, please be aware that you have multiple species present that can either act as the oxidant and reductant. For example, if I place a strip of magnesium metal into an aqueous solution of copper sulfate, you might assume that there may be 2 or 3 species present, but there's actually a total of 4 substances that can potentially take part in the redox reaction. Inside of this beaker, you've got the magnesium metal, copper 2 ions, sulfite ions, as well as the water molecules since the electrolyte is aqueous. In this lesson, it will be our objective to predict whether a spontaneous reaction will occur and identify the 2 species undergoing the redox reaction. To do this, I've got a neat trick that can help you accomplish this. The first thing that you want to do is that you want to circle all of the potential reactants present in the cell on your electrochemical series. In this generic example, let's say I've got the following chemicals present: A2+, A, B2+, and B. From there, you want to draw a backward Z shape between the strongest oxidant with the strongest reductant based on the species you are working with. On the electrochemical series, we know that the strongest oxidant is found on the top left side, whereas the strongest reductant is found on the bottom right side. As a result, I know that the spontaneous redox reaction will occur between A2+ and B. Furthermore, if we want to prove that this reaction does occur spontaneously, what we would need to do is calculate the overall cell potential, and you'll find that in this example, the value will be greater than 0 volts. I would like to add that a redox reaction will not occur spontaneously for any other combination. So this means it isn't possible for B2+ and A to react spontaneously together. Let's look at some real examples using the electrochemical series. To start off, I will first circle all of the species that's present on my electrochemical series. As a reminder, I've circled water as well, since water molecules are present in the aqueous solution. Based on this information, I know that the redox reaction occurs between the strongest oxidant found on the top left reacting with the strongest reductant found on the bottom right. Hence, I can draw a backward Z shape with copper 2 and magnesium metal. To prove that this is a spontaneous redox reaction, I will calculate the overall cell potentials by subtracting the potentials of each half cell, and as you can see, this is going to give us a value above 0 volts, thus proving that this reaction is indeed spontaneous. In this second example, we are given 3 half equations and we want to find out whether mixing certain reactants together results in a spontaneous redox reaction. For part A, we are reacting bromine with magnesium 2+ ion. Because both species are oxidants, a redox reaction cannot take place since a redox reaction requires an oxidant and a reductant. For part B, the reaction between magnesium 2+ and nickel is also not going to be spontaneous. We know that this is the case since we are unable to draw a backward Z shape, but the reason why it is non-spontaneous is because the overall cell potential was not above 0 volts. For part C, we should expect a spontaneous redox reaction between nickel 2+ and magnesium metal since we can draw the backward Z shape. Furthermore, if we do calculate the overall cell potential, we'll find that it is greater than 0 volts, thus proving that it does result in a spontaneous redox reaction. I would now like you to practice and check for your understanding. Please pause this video now and then play again to check your answer. Based on this equation, we should predict that this redox reaction will occur non-spontaneously because the overall cell potential is less than 0 volts. In the next question, you will need to use your electrochemical series to predict whether the following reactions occur spontaneously by calculating the overall cell potential. Please pause this video now before you hear the solutions. To start off, I've highlighted the reactants on the electrochemical series. We can draw a backward Z shape and its overall cell potential is also greater than 0 volts, which demonstrates that this reaction proceeds spontaneously. In the second example, a backward Z shape cannot be drawn and the overall cell potential is a negative value, hence this reaction will not occur spontaneously. Similarly, this is also the case for the third example as well. As you can see, the cell potential is a negative value. And in the last example, a backward Z shape can be drawn and we find that the overall cell potential is a positive value. Hence, the redox reaction between tin 2+ and bromine is spontaneous. Before I end this video, I want to talk about the reliability of our predictions and when our predictions may not be accurate. Firstly, Although we may expect a spontaneous redox reaction to occur when the overall cell potential is positive, we may not be able to observe this reaction at all because the rate of reaction might be extremely slow. Hence, it may appear that no reaction is actually taking place. Please do not make the assumption that the word spontaneous means that the reaction is fast. Secondly, our predictions may not be accurate if we are conducting the redox reactions under non-standard conditions. If we change either the concentration, pressure, or temperature in which these reactions occur, please recall that the magnitude of the cell potential for the half equations will change, which will therefore change the order of the half equations on the electrochemical series. As a result, the predicted reaction may be less favorable if we completed it under non-standard conditions. This is the end of the video. I hope that you were able to meet both of the success criteria. Thank you for watching, and I'll see you guys again in the next one. Bye.